Hello. In our previous video, we went through the various parts of a circle. So we don't want to waste time here. Let's straightforward move to the theorems. All right. So let's consider this theorem. For the first theorem, it states that angle subtended at the center by a chord or an arc is twice the angle at the circumference. All right. So for this particular theorem, let's once again assume that this is our center. Okay, and we are having a chord, so let's say this is the chord. All right, so we have the chord AB, and this chord is going to subtend an angle at the center. So we are having this. So the angle that the chord is having at the center, let's say, is theta, is the angle here. Now when it happens that this same chord is having an angle at the circumference, then this theorem works. Okay, so you have another angle here. Let's say it is alpha. Then the angle that this chord AB is having at the center there, that is the theta, is 2 times the angle that the same chord AB is having at the circumference, that is alpha. In that case, then we can have again the alpha to be equal to the same theta over 2. That is the concept here. So it can be a chord or an arc. It can be this arc. Yeah, the arc is having an angle at the center. This is the angle that the arc is having at the center. And the same arc is also having another angle, indeed, at the circumference. Okay, so that is the property here. Now, this property can be expressed in different forms. So let's consider another form here. So let's assume that this is indeed our center. Okay, now let's draw a diameter. This is our diameter. Let's get another radius here. From what we are having here, if you are to consider indeed this particular arc, you ask yourself, is it having an angle at the center? Yes, and that is, let's say, theta. Again, the same arc that we are having here, is it having another angle at the circumference? Yes, and that is what we are having here, this particular alpha. So indeed, there is that relationship between the alpha and then the theta, and it is the same theorem that angle subtended at the center by a chord or an arc is twice the angle at the circumference. So in that case, we are still going to have our theta being equal to 2 times our alpha, and again the alpha will be equal to the theta over 2. Again, the same theorem can be expressed in another form. So let's assume that we are having this particular circle and we have our center. Okay, assuming that we are having these 2 radii. Okay, so we have an arc subtending an angle at the center. So this is the arc and we have an angle at the center. Okay, so let's say the angle is theta. All right. Now, if it happens that the same arc is having another angle at the circumference, so we can have it in this form. Indeed, the same arc is having another angle at the circumference. And let's say that angle is alpha. Then the same theorem is going to work here, that the angle at the center, so the theta, will be equal to 2 times the angle at the circumference, that is alpha. And again, you are still going to have the alpha to be equal to theta over 2. Again, let's assume that we are having our center. This time around, the angle that we are having at the center there is reflex angle, an angle which is more than 180 degrees. So let's assume that we are having it like this. Okay, so if you are considering the arc, then you are going to consider whatever arc that you are having here up to the side. And what angle is it having at the center? This is the angle that is having at the center. So let's say that is theta. So the angle at the center indeed is going to be 2 times the angle that the same arc is having at the circumference. So we can have the same arc having an angle at the circumference and can be from this point up to the side. So the angle that we are having at the circumference is this particular angle, and that is alpha. So yes, the theorem also works here, that the angle at the center there is twice the angle at the circumference. So the same property is going to work here. That is, theta will be equal to 2 times alpha. That is another aspect of the same theorem. All right. So now let's consider some examples on this particular theorem. Now we are having these questions and we want to find the marked angle. All right. Let's assume that the center is O, point O. Okay. If that is the case, then from what we are having here, the angle marked Y is the angle at the center. And that angle at the center, that is angle AOB, indeed will be equal to 2 times angle ACB. That is angle ACB. Because the angle AOB is the angle at the center, this particular angle. And then angle ACB is what we are having here. If that is the case, then angle AOB will be equal to 2 times the 32. And indeed, this is going to give us 64. So our angle marked Y is equal to 64 degrees. That is how we can solve this particular question. Now let's consider this one too. Are we having an angle at the center? Yes, the angle at the center is the 75 degrees. That is angle AOB is 75. And this angle indeed will be equal to 2 times angle ACB. If that is the case, then our angle AOB was what? 75 degrees. And this will be equal to 2 times our angle ACB. ACB was marked X. In that case, we have to solve for X. So we divide this side by 2. We divide this side 2 by 2. And indeed, we are going to get our X to be equal to 37.5 degrees. Okay, now let's consider another question on the same theorem. So let's assume that we are having this, indeed the angle at the center, that is the reflex angle MON, is 220 degrees. So angle MON, that is reflex angle. Okay, this angle indeed will be equal to 2 times the angle at the circumference. So it's going to be 2 times angle MRN. All right. If that is the case, then our 220 degrees will be equal to 2 times our x. So indeed, we have to solve for x by dividing both sides by the 2. So we are going to divide this side by 2, this side by 2. And we are going to get our x to be equal to 110 degrees. All right. Let's consider this one too. For this particular one, we are going to focus on just M. If you look at what we have in there, yes, this is an arc. This arc is having an angle at the center. So the angle that we are having at the center there, that is angle ROQ. And this angle will be equal to 2 times the angle that the same arc is having at the circumference. And that is angle RPQ. If that is the case, then our N will be equal to 2 times the angle at the circumference. And that is 32 degrees. And our N indeed will be equal to 64 degrees. That is the theorem that we are dealing with. The angle subtended at the center is 2 times the angle at the circumference. All right, so this is where we are going to end this particular lesson. Check out for the next theorem in the next video. Thanks.